Today in Engineering Newswire, we're flying high with DARPA's demonstrator aircraft, slithering through seabeds with a serpentine robot, and generating electricity with P. DARPA has successfully tested a miniature version of its vertical takeoff and landing experimental plane, otherwise known as the VTOL X-plane. According to the builder, Aurora Flight Sciences, the subscale vehicle demonstrator prototype of the Lightning Strike recently completed a series of takeoff, hover, and landing maneuvers at an undisclosed U.S. military base. The flight was conducted by an Aurora team from a ground control station with oversight from the U.S. government officials. Weighing about 325 pounds, the prototype is 1/5 the scale of the final VTOL X-plane. It uses wings and canards made of carbon composites and 3D printed plastics to produce the highly complex structures while maintaining a minimal weight. Upon completion, the full-scale Lightning Strike will be the first to use a distributed hybrid electric propulsion system with synchronous electric drive. The program eventually hopes to develop a VTOL aircraft that will achieve a top sustained flight speed of 345 to 460 miles per hour, with a 60 to 75% increase in hover efficiency over existing VTOL aircraft. The full-size demonstrator is expected to be built within the next year, during which Aurora's team will focus on further validation of flight control system and the aircraft's overall configuration.
If you're not a fan of slithering snakes, then it's time to look away. The Ilume Robot was developed to glide through the water like a snake in order to carry out maintenance tasks on the seabed. Ilume is a spin-off company of the Norwegian University of Science and Technology, which collaborated with the oil and gas company Statoil and Norway's Kongsberg Maritime in developing the robot. The snake-like robot is designed to slither in and around underwater rigs, cleaning, performing visual inspections, and even attaching itself to certain components to adjust valves. The basic idea is to let these robots do inspection and light intervention jobs on the seabed, thus reducing the use of large and expensive vessels. And with its slender and flexible body, the Ilume Robot provides access to confined areas that are difficult to access with existing technologies. The developers say the robot can be installed permanently on existing and new underwater machinery to act as a self-going janitor on the seabed. Whatever task the robot ends up performing, I just hope it stays out of sight and deep under the sea.
Researchers at the University of Bath have developed a mini microbial fuel cell that can generate electricity from pee. In the near future, the device could be generating much needed electricity for remote areas at very little cost. Microbial fuel cells are devices that use bacteria to perform reduction-oxidation reactions on organic materials, such as urine. When such reactions occur, electrons are swapped around between molecules and electricity is produced. By having this reaction take place within a closed system with an anode and cathode, a battery is formed. While urine-based batteries are already in existence, the $1.40 to $2.90 price tag of the new device and the 1 square inch size are a great improvement. The next step for the researchers is to figure out how to up the energy output. Currently, a single microbial fuel cell can only generate 2 watts per cubic meter, about enough to power a cell phone. However, they've already figured out that by extending the electrodes in the cell from 4 to 8 millimeters, power output increased tenfold, and that stacking the batteries could produce even greater electrical output. Let's hear it for P and the researchers studying it.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For the PD&D channel, I'm Keely Duffy, and this has been your Engineering Newswire.